Welcome back, Physics fans. Yes, here we go. We're trying some of those quiz questions at the end. Here's quiz number 1. At the end of what? On the Moodle. At the very back of the Moodle, at the bottom, it says work quiz number 1. This is my version of it. Your numbers will be different. A 55-kilogram remote control car accelerates from rest to a speed 6.8 meters per second in 16.5 seconds. There is a coefficient of friction of 0.38. Determine the acceleration of the remote control car. And then there's 7 more questions, all on the same setup, but it's all about work. But we have to get some stuff first. So free body diagram. There's a normal force up. There's a force of gravity down. There's some sort of push force by the motor probably, and then there's a frictional force slowing it down. Okay, so determine the acceleration of the car. This is kinematics because we have VI, we have VF, and we have T. The acceleration is an easy one. Acceleration is the change in velocity over the time. The change in velocity is 6.8 meters per second, and the time is 16.5 seconds. Pull up the calculator. So 6.8 divided by 16.5. So the acceleration is 0.41212. And then after this, of course, we should probably put a direction here forward. They're now asking for the net force. F net is just going to equal ma. And the mass is 0.55, and the acceleration is 0.41212. So when we put those together, times 0.55, we get 0.22667. Newtons, and that still would be forward if we had to put a direction in there. And then it's asking for the frictional force, and the frictional force is just going to be mu mg. It's on level ground, because we're not told otherwise. And the mass is 0.55, and the g is 9.8. So we put those together, we get 0.38 times 0.55 times 9.8, and we get 2.0482. Okay, now let's write down Newton's second law. The sum of the forces is equal to F net equals to ma. So I'm going to ruin my free body diagram, but here we go. It's going that way. So the push minus the frictional force, winning, subtract losing. F push subtract the frictional force is equal to ma. F push minus the frictional force of 2.0482 is equal to ma, which is 0.22667. So add those together to get F push. Bringing that on over. So we take that last answer, that, and add it to that. And we get 2.275. 2.275 newtons. Okay, it's pretty good. Now we have to get the distance. The distance traveled, given these three things, is going to be VI plus VF all over 2 times the time. So that's going to be 6.8 all over 2 times 16.5. So 6.8 divided by 2, then multiplied by 16.5, and we get 56.1 meters. So, as I said here, so what forces do we have? We have the net force, we have the frictional force, and we have the push force. And each of them does work, at least does work according to the physics term of work, which is a force times the distance. So the distance is in this direction. So the push force is in this direction, the net force is in that direction, but the frictional force is in the opposite. So the frictional force, the work done by the frictional force, will be negative. So the work done by the net force, kind of like the network, will be the F net times D, and that's going to be 0.22667 times D of 56.1. The frictional force work done by the frictional force is force of friction times D, which is going to be negative 2.0482, and that's going to be then times 56.1 meters. And the work done by the push force, so how much work did the motor do? And that'll be F push times distance, which is going to be 2.275 times 56.1 meters. So all these are how much work each of these forces do. Let's just go. So here are the answers. 0.22, which is the net work, which would be the done, and then the 2.04 would be the frictional force, so that'll be the work done by the frictional force, and that'll be negative. And then the push force. So here we go. Work. 12.716. And this next one is 114.904. 114.904. And last but not least, 127.620. So the work done by the push force plus the work done by the frictional force, and this will be negative, those two added together should equal that. And they do. You can take a look at it. You can take that number plus that number, and that gets the net work done. Okay, one more. Emphasizing again before we do the last question, the net work is when we add up all the works of all the different forces, we get the net work done. And we make sure that these are all in joules. Okay. And yeah, you can see that this works out just beautifully. Last question is, what is the kinetic energy? So it looks like a totally different question than this whole thing because we could have done the kinetic energy at the very beginning. Okay, it could have been question number 1. What is the kinetic energy? Kinetic energy is equal to 1/2 mv squared. And that's going to be 1/2 the mass, 0.55. And it's not going to be the initial, it's going to be the final because the initial is 0. And so we have to do the speed, 6.8 squared. So we pull up our calculator and we put 0.55 divided by 2 multiplied by 6.8 squared. And what do we get? 12.7. Hey, didn't we have that already? Boom, it is there. That's amazing. We get the net work done is the kinetic energy. 12.716. Does that make sense? Initially, it has no energy because it's at rest. And then we add in 127.62 joules by our push force. But friction is taking out 114. So what's left is what can be gone to kinetic energy. That's just the conservation of energy. That's beautiful. Very good. So the kinetic energy initial plus the work of the push minus, or you can go plus the work of the frictional force, which will actually be a negative, will equal the kinetic energy final. This is the change in energy. How much are you changing it? You're adding, in this case, we're adding 12. It starts at 0, we add 12 to it, and that's what our kinetic energy is. How do we know add 12? Take that plus that. We get 12. Beautiful question. Thanks for paying attention. Go back, rewind, pay attention, enjoy. Let's listen to the jingle. Here we go. Bye-bye.